Hello everyone, Mr. Fawcett here, and we are back with another AP Calculus lesson. Today we're going to talk about how to find the area between two curves using integration. And hopefully if I asked you the question, what does the area underneath the curve and an integral have in common, you could kind of give me a reasonable answer for that. Now we're just going to go one step further, and instead of finding the area between a function and the x-axis, we're going to find the area between two functions. And you'll notice it's pretty similar to what we've been doing with a couple minor changes. Let's have you think about it. Let's do a little brainstorming before we just kind of show you how to do it. Here we have an area on the graph. It's shaded in black, and it is between the functions f of x and g of x. This area goes from x is equal to a, so that's where it starts, and it ends at x is equal to b. So based off of what you know about integration and the area underneath a curve, or the area between a curve and the x-axis, could you try to set up an expression to find this specific area? Give it a shot. Before you continue with the video, at least come up with some equation. So you want to come up with some equation, area equals something. Even if you don't think it's correct, come up with something and then see how close you were to what it actually should be. Okay, so we're going to kind of break this down step by step, and then we'll see what the answer looks like. You'll be able to compare yours to what the actual way to do it is, and then we'll move forward. So one thing we could do is we could kind of find multiple areas and use some subtraction. Right? So we could start by finding out the area between the blue curve and the x-axis. So this area in black right here. So we're not even worried about the red curve for now. Well, this area should be pretty straightforward. We're going to take the integral from a to b of g of x dx. That would give us that black area underneath the curve. Now, if I wanted to find the area underneath the red curve along the same interval, it's going to be the same integral, except we're going to swap out g of x for f of x. So that would give us this area right here. Now, I don't want either of those areas, right? I want kind of the difference between those two areas, right? I want to take that entire area that we found using the blue and subtract off the piece that we found over here using the f of x function. So let's go down to this final picture right here. So to do that, again, we're just going to take the difference. Let me do this in black. The area is going to be equal to what I found for blue. So the interval from a to b of the integral g of x dx minus the integral on the interval a to b of f of x dx. And what we know about integral properties, right, this would work. In fact, I'd urge you to understand it this way, right, because I think understanding it using the difference in areas makes a lot of sense. You have two different integrals that you're subtracting. But we could combine these, right, using our knowledge of integral properties. And maybe you want to pause the video right here and think about what I'm going to do next, right? How could we combine the red and the blue integrals into just one integral? Well, we do the integral from a to b, and I could just subtract the functions before I take the integral. So g of x minus f of x dx. And again, sometimes it may be easier to do the subtracting part first. Sometimes it may be easier to integrate first. But knowing we have both of these options can make it nice. It gives us a choice. Well, this is the area formula for finding the area between two curves. It is important that we make sure f and g of x are continuous, and f of x is less than g of x for all the x's in that interval. If we go back up here Again, what we're really doing here is figuring out what the top function is and the bottom function. And I know it's weird to write, the bottom up there and the top down there, but remember, we're only looking for what is the top and bottom over this interval from a to b. And over that interval, g of x is our top function. That function is greater than f of x for every x value on the interval a to b. So again, another way to write this, right? We could say the area is equal to the integral on the interval a to b. But instead of thinking about it as specifically those two functions, we could just think of it as the top function minus the bottom function with respect to x. Again, it's important to make sure that one function is greater than the other function over the entire interval. And we'll talk later about what happens if they switch, right? It's possible that, or maybe, let's say we're not going from a to b, we're going to go from a to c. So for this part of the graph, right, this area, it's actually f of x on top and g of x on the bottom. So we'll talk about, how we have to switch up our integral. Maybe we need to add something to it. If somewhere during the interval, the functions switch from one going on top to one being on bottom, etc. Now you may say, Mr. Fawcett, this makes sense. I understand that we're just finding the difference in area here. It doesn't seem too complicated, but the example we looked at, both functions were above the x-axis. Would this integral formula work if all of a sudden our functions were below the x-axis? Because then we'd be dealing with, some negative areas, and does the formula still hold up? Well, let's take a look at that. We do want to make sure this idea is going to work regardless of where the functions are placed. So here are two functions, f of x and g of x, are both below the x-axis. All they did was use different letters for the interval. We're going from m to n rather than a to b. Let's break this down step by step, and you may actually want to do this on your own first, just to see if you can understand the reasoning on your own before you hear someone tell you. So what I encourage you to do is pause the video and go through these 3 steps again. Right, so we're going to first think about, okay, find the area between one function and the x-axis, the area between the other function and the x-axis, do the subtraction, and do we think we'd come up with a number that makes sense? Now, I will say that when we found the area between one function and the x-axis, we were allowed to have a negative area. When we are finding the area between two curves, though, our answer should always be positive, right? So if I'm finding the area between two curves, that answer should always be positive. So when you think about this, think about whether the answer you get here would be positive or negative. If your answer is negative, you may have messed something up in what your integral equation would be. Okay, so if I'm finding the area between f of x and the x-axis, well, area is equal to the integral on the interval m to n of f of x dx. Well, this area is going to be negative, right? That area is beneath the x-axis, so we would consider it negative. If I think about the blue, well, same idea, same interval, m to n. The only thing we're changing in our integral expression is that we're using g of x rather than f of x. Likewise, this area would also be negative because it is below the x-axis. Now, we have to think, would our integral equation for area between two curves that we looked at above, would that make sense to use here when both of our functions are beneath the x-axis? We know that the area we're looking for, right, this area in green, okay, that area should be positive. When we're finding the area between two curves, we are always going to end up with a positive area. Well, if I do this subtraction, will we get a positive area? Let me go down to this final diagram down here. Let me come up with our final integral expression. Area is equal to the integral on the interval m to n of f of x. And actually, let me do the whole thing. Let me do the whole thing first for us. Using the wrong color here. F of x is our top function here. Okay, so would that give us a positive area if we subtract the blue area from the red? Well, remember there was more area between the blue function and the x-axis than there was between the red function and the x-axis. Right? There was, and that area is negative. The area between the blue function and the x-axis, that area was negative. So was the area between the red function and the x-axis. But the thing is, right, if I'm subtracting a negative area, well, it's going to be like adding that area. So I'm going to have the negative area from the red, and we know that's smaller than the blue. So I'm just going to pick a number. Let's say that area is negative 10. So I'd have negative 10 minus, well, I know my blue area has to be more negative than the red, right? We can just see from the graph visually that it's going to be more. So let's say that is negative 45. Well, when I subtract that negative 45, it's really going to be like adding 45. Right? So in essence, this is going to give us negative 10 plus 45, which would give us 35, a positive area, which makes sense. Right? I did tell you that the area between two curves is always going to be positive. So this right here, our final area, this area in green, right, the area between the red and the blue curves, that is going to be a positive area, which makes this equation make sense, right? Because this equation would always give us a positive area because we're subtracting a larger negative area than, in this case, what the top function would give us, right? What f of x is giving us. So hopefully it's clear to see why this equation, this integral equation, would still work if our functions were below the x-axis. Let's look at the final scenario where one of our functions is above, one of our functions is below. And again, I encourage you to think through this on your own first. Go through the steps of just, looking at the area underneath the blue curve, the area between the red curve and the x-axis, doing the subtraction, and trying to decide whether that formula would still give us an answer that makes sense. And it may help to throw in some numbers there, right? Just to choose some random numbers. One of those areas should be positive because it's above the x-axis, one should be negative, etc. Okay, and actually one other question you could think of is, what if this red area was actually larger than the blue? Would that make a difference? Would our final area still end up being positive? Could it be negative if we use that equation from above? So just things to think about. Think about all the different options while you're trying to decide whether this integral formula that we've come up with will still hold true for this example. Okay, so I'm trying to find the area between the blue and the red. Well, if I find the area just between the blue curve and the x-axis, we've done this many times before, well, specifically twice up above. Integral from m to n of g of x dx. This area would be positive, right? It is above the x-axis. Our integral for the area between the red function and the x-axis, also from m to n, but this time of f of x dx. And this area would be negative. Now, you may think, well, here it actually looks like I need to add the areas together, right? Because they're not overlapping. So if I have two separate areas that I want to figure out the total area, and they're not overlapping, well, wouldn't it just make sense to add them together to get the total? Well, if one of those areas is negative, though, and you add it to the other one, it's going to be like subtracting, right? If I just add these areas together, then what I'd really be doing, right, I'd really be subtracting the red area from the blue, right? I'd start with the blue and I'd add the red to it, but the red's negative, so it'd be like subtracting. I don't want to do that though, right? I actually want to add the total area of the blue, the positive version, and I want to add it to the area of the red, right? Because it should be more area than just the blue, right? Together, these should have a bigger area than just the blue area beneath the curve. So what that means I need to do is I need to subtract off the red area. I need to subtract off the area of, or between the bottom function and the x-axis. So if we go down here and we think about this formula again, my top function is blue here. Bottom function is red. That's still blue. Well, let's just choose some numbers here. Let's choose that this area, we'll say that's equal to 20 because it's positive above the x-axis. We'll say this area right here is equal to negative 10. Well, I do 20 minus negative 10. That's really like adding the negative 10. All right, so I'd end up getting 30. Which makes sense, right? Because the area here, the total area should be larger than the blue. If I just added the area of the blue and the red, I do 20 plus negative 10, that would give me positive 10. But that wouldn't make sense, and you can think about it visually, right? The total area right here in green should be larger than just the area of the blue. So this formula does make sense because it still gives us an area larger than what we started with, which is what we're looking for. And it makes sense because we're subtracting a negative number, which in turn is like we're going to be adding that number to our initial area. Okay. A lot to kind of think about there, but hopefully it gives you an understanding of where that formula comes from, why it works. We are now going to look at applying it to 2 practice problems, I believe. All right, let's go ahead and look at this first one down here, this multiple choice question. We are trying to find the area of the shaded region over there in the graph. You will notice that the intersection or the interval points, the starting point of that shaded region as far as the x value goes and the ending point of that region as far as the x value goes, they are not labeled. So we do need to figure out a way to find those intersection points. Looks we know about where they are, right? Although there is no scale here, but we do know one's pretty close to the origin, and we know one should be a positive number to the right of that. But you'll need to figure out how to find those, and then you'll need to apply the integral formula. So pause the video, see if you can work your way towards one of those multiple choice answers, then hit play and see how you did. Okay, so the first thing is we need to figure out where these endpoints are of the interval, and we're looking for the x values. Well, we're just going to set the functions equal to each other. So I'm going to get 5x minus x squared is equal to 2x. I said x squared, I wrote 2x, let's fix that, minus x squared. I'm going to move everything to the right-hand side and set it equal to 0. I'm going to get x squared minus 3x. If I factor out an x, I get x minus 3 inside parentheses. I know that x is equal to 0 and x is equal to 3. Well, those are the two x values at where the functions intersect. So if I look here, right, this is going to be 3, and this does end up being the origin, so 0. So my interval is going to be from 0 to 3. Now we need to just implement that integral equation. I'm going to erase this. You guys probably have a little bit more space in your paper. And let's set this up. So I have the area between the curves as the integral from 0 to 3 of the top function minus the bottom function. Our variable here we're integrating with respect to is x. Now I specifically didn't tell you which function's the top, which one's the bottom, because there's a couple ways to figure it out. One, right, you could think about, well, one of those is a line, one of those is a parabola. Well, we know this one's going to be the parabola. We know that this is the linear function, that's the line, and we can identify those from the graph. So right here we have y equals 2x. Here we have y equals 5x minus x squared. Now, sometimes it'll be easy to tell visually which function is your bottom, which is your top. If it's not easy to tell, here's another way you can figure it out. Very easy, just, it's going to take a few seconds. Pick a number on your interval. I'm going to pick 1. That's between 0 and 3. Now, you can substitute into your functions and see which one has the greater y value, right? That will tell you which one is your top function, which one is your bottom. So if I do the first function, y equals 5x minus x squared, and I substitute in 1, I get y is equal to 5 minus 1, y is equal to 4. If I look at my other function, y is equal to 2x, substitute in 1, I get y is equal to 2. So again, that's another way to tell that y equals 2x is going to be your bottom function. Y equals 5x minus x squared will be your top. So let's make that substitution, then evaluate our integral. I'm going to end up getting 3x minus x squared dx. Once I actually take the antiderivative here, I'm going to get 3/2 x squared minus 1/3 x cubed. And I'm going to be evaluating that on the interval 0 to 3. When one of your limits of integration is 0, that makes it nice. If I substitute in 3, I get 3/2 times 9 minus 1/3 times 27 minus, well, 0 minus 0. Because when I substitute in 0 to both of those terms, we get 0. If I simplify, I get 27 over 2 minus 9. That is going to give me 4.5. I'm running out of room, so I just kind of did that in my head. 4.5, which is equal to 9/2. So that would be B in this case. Okay, let's do one more example. Let's just do this example right here. This isn't one where we actually have to work anything out. We just have to think about it in terms of what's our top function, what's our bottom function, etc. So pause the video, read the question, and think about what would the correct integral expression be for that shaded region to the right. Okay, well, we can kind of build this, right? If you didn't have the multiple choice answers, we could still figure this out. We'd have the integral from a to b of our top minus our bottom. Looks like we can already eliminate some answers, right? Our interval deals with x values here. We actually will do some intervals where we're using y values, but we'll talk about that during a later date. So we can automatically eliminate a. Well, what's our top function? Our top function is this horizontal line right here. Right, well, the equation of that horizontal line is just going to be y is equal to d. So our next part is the integral from a to b of d minus our bottom function. Our bottom function is f of x, so minus f of x dx. Well, that looks like it matches b, so we should be good to stop right there. You can think about why the other ones don't make sense, right? None of these have an integral in them. We know that our equation is going to deal with an integral because we're finding the area between two curves, which is, essentially part of a process of finding the area between both of the functions and the x-axis and doing some subtracting. So c to e wouldn't make much sense because there is no integral going on there, and we know that that has to be part of our equation. I think that's going to do it, though. We've been going long enough. As always, enjoy the rest of your day. We will look forward to seeing you next time.